Hello everyone, welcome back to my channel. This is the next video of the series Ease into Coding along with complexities. So, if you must be following this series from the start, you will be knowing that in this series we covered multiple problems from various coding platforms and we tried to solve them using multiple approaches, starting from the brute force approach. But as it is quite evident, you must be knowing that using brute force approach we often end up getting a TLE, that is a time limit exceeded error. In order to avoid this, we tried making our solution more optimal. Before that, if you haven't checked my previous video from this series, you can check them by clicking on the I icon above. Also, if you haven't subscribed yet, don't forget to hit the subscribe button below and also hit the bell icon to never miss an update. So, without wasting any further time, let's get started with this video.
This video, I've taken a question again from LeetCode. And this time, I've taken up the question that is the longest palindromic substring, whose difficulty level is medium. I'm quite sure that most of you must have come across this question in one of the technical interviews, or must have gone through this question. If not yet, I've provided the link in the description box below. You can always go over there and check out the question. I would recommend pause the video, go first try to frame a logic for this question and then come back to see what are the various steps in order to reduce the complexity for the similar problem. Coming back to where we were, if you must have gone through this problem, you will be knowing that in this problem you will be provided with an input string, and operation that we need to do is to return the longest substring, which is a palindrome, or in short, return the longest palindromic substring of that string. For that, as you can see, we are given with an input example, that is, if the input string is BABAD, and it's quite obvious that the longest substring, one of the longest substring would be BAB. Also, ABA also would be a valid answer over here. Also, you can just look at the example 2 as well. That would give you a clear idea. So here we have the input as cbbd, and it's quite evident over here again that these two B are going to form the longest substring. Also, to bring to your notice that if a string is having completely different characters, take a string, for example, that is A, B, C, D, E with a length of 5. So keep in mind that this will also return A as the answer, because individual character is also considered as a palindrome. So in short, every string will have a substring, even it can be of length 1, as in the case I've given in the example. So now let us quickly see what are the approaches we can do in order to solve this problem. So the first approach that would come into anyone's mind is definitely the brute force approach. Now, how do you think the brute force approach will go? For that, let us quickly move to the whiteboard. As you can see, here I've taken up 2 loops in order to find the all possible substrings that the string will have. For that, one of the loop variable is going to iterate from 0, and it is going up till the length of the string -1. As you can see over here, our I is starting from 0 and going up till the string's length -1, and our J is going to tell us the length of the substring that is going to be formed, because as you can see inside this loop we'll be using a substring function. And if those people who don't know what a substring function is in C++, in substring function it accepts 2 arguments inside it. The first argument is the index of the string from where the substring is to be framed, and the second argument is the length of the substring that will be made. So in this case, I will be the first loop variable. I is going to be the index from where it needs to start, and J will denote the length of the substring. So I think most of you must have understood that using these 2 loops we will definitely get all the substrings, like you must have already figured out in the right for the first iteration, that is I equals to 0, our substrings would look something like this. And just quickly glancing through the code, when j is 1 and I is 0, we will have b. When I is 0 again and j is 2, we'll have b and a as a substring. And similarly BAB, BABA, BABA, and then we'll have BABAB. That is, j is going up till from 1 till the length minus 1, length minus I. And what is I over here? 0. That means we are going up till, in this case, since BAB, this entire string is of length 5, we'll be going up till 5. So with our first iteration, when I was equals to 0, we came up with so many substrings. I've just taken that for instance right now to make you understand. Now this was all the explanation regarding the substring formation. Now what are we going to do? Once we get the substring, we'll be quickly going through the code as well. First, I'm just explaining you what we'll be doing over here. Once all the substrings are formed, we'll be storing that in some string variable, and then we will be reversing that string and storing it in some other variable. Let us say it that way. And then we'll be comparing those two, because we know it very clearly that what basically a palindrome is, that it is equals to, when you reverse the string, these two, if there is a string and if you reverse that string, these two will look alike. And that is what a palindrome is. And so once we reverse it, and then we try to check its equality, and if that comes as true, then definitely that substring is going to be a palindrome. So having discussed all this, let us quickly go back to where we were through the code. So you must be seeing over here, we are accepting the string s as an argument for this function, and then we are also having a string res, which will store the resultant longest palindromic substring for this string. Having said that, we also have int max equals to 0. Basically, this is going to store the length of the longest substring that we have encountered. As I previously explained while giving you the logic for our brute force method, these two loops, that is I equals to 0 going up till the string dot length minus 1, and j equals to 1 going up till string dot length. These two are going to be helpful while forming the substrings, as we'll be using s dot substring and I comma j in order to retrieve all the possible substrings this string will have. And that's the reason this method is known as brute force, because in brute force we look for all the possible solutions that we can have for a given problem. Then once that is done, what we are going to first check, our main priority is whether the substring is a palindrome or not. But there is a need for checking that only if its length is greater than the maximum length we have until now encountered. And that's the reason we are checking for dot length, and then we are checking whether that is greater than max. And in this case, as we had initialized max equal to 0, so definitely for the first case, that is for the b, since the s dot substring for I equals to 0 and j equals to 1, that is the very first iteration, will return b as over here. So for b, we are going to check that b's length, that is 1, is greater than 0. Because max is 0 over here. Yes, it is true. We'll be entering this if condition. Then we are going to check, we are going to store, we are using a string s1 just for storing the substring that was so formed. After that, what we'll be doing is, we'll be reversing this s1, that is the substring that we have stored. And once we have reversed that, we'll be again comparing that string, that is the reverse substring, with its original substring. As I told you, if the reverse substring matches with the original substring, that is a palindrome. And if it doesn't matches, it is not a palindrome. And to bring to your notice that the compare function that we have used over here accepts two substrings as not, we cannot say that it accepts it as an argument, but if there are two substrings with the name s1 and s2, it goes something like this: s1 dot compare. When we write that way, compare, and s2, basically it returns any of the three values. If it returns negative value, that is less than 0, then we can clearly say that our S1 is less than S2. And if it returns a greater value than 0, then we can say our S1 is greater than S2. And if it returns a equals to 0 value, then we can clearly sum up that our S1 is double equals to S2. That means our S1 not double equals to, single equals to S2. That means our S1 and S2 match. That is something our compare function does. But as you can see, I've used a not of S1.compare substring. And the reason I'm doing this is, if both the strings are going to the reversed substring and the actual substring are going to be equal, then it is going to return a 0. But our if condition only works for true condition. 0 is considered as false, so we are negating it. And in short, this if is checking whether the the original substring and the reverse substring are equal. And if it is equal, what we are going to do is we are going to make max, that is a maximum length of this palindromic substring, is going to be set as the length of S1, or it can also be the length of S dot substring I comma j, and then we are going to store S dot substring inside res, which is our resultant substring. And this way, this entire if is going to work for all the possible substrings, and in that way we are going to find out which is going to be our longest substring. And as you must have already figured out, that what would be the complexity for this solution, since we have encountered one loop, two loop, but still many of you must be guessing that the complexity is n square. But to your surprise, I would like to say that the complexity of this solution is n cube. And the reason for that is, if you go through the documentation of compare function, as you can see it over here, that when you go through this, you will find under the complexity section for the dot compare function of C++, and the complexity is given as linear. So although it's unspecified, but generally it's taken linear. So let's go for the worst case, and for that, even the complexity of compare function will add on to the overall complexity. So it's quite evident that the overall complexity, time complexity, would be the order of n cube. And since we are not taking any extra space, our space complexity is going to be order of 1. So although we have not taken up some extra space, but our time complexity is immensely very large, which will definitely probably not make this solution work. And let's quickly check it out. As you can see, this is the same solution. Let us quickly check it out, that what is the solution, what is the result we'll be obtaining after submitting this solution. So as you can see, we got a time limit exceeded error, TLE, which is also known as TLE, and the probable input, the last executed input, was probably a very long string, as you can see it over here, something like this. So as we have figured this out, that this solution is not working, let us quickly look on to what can be the other possible steps in order to reduce this complexity and come up with a better complexity. So the second approach that we will be using over here is the dynamic programming approach. Yes, you heard it right. To solve this problem, we have to finally use the dynamic programming approach, because here this longest possible substring, palindromic substring, is something that can be easily solved using dynamic programming. Let us quickly look, for the ones who don't know what dynamic programming is, for them let us quickly look through the definition of dynamic programming. Definition of dynamic programming goes something like this, that is, dynamic programming is an approach which is similar to divide and conquer. When those who don't know what a divide and conquer technique is, in that we divide the problem into multiple problems, and we try to solve all of those subproblems. But unlike divide and conquer, what we'll be doing over here is we'll be using those sub problems in order to, we'll be combining those sub problems and using the memory, we'll be storing those sub problems in some memory, and using that memory we'll be trying to achieve to the most optimal solution. Those who don't understand what this textual definition is, let me quickly explain you in short what exactly dynamic programming is. So just consider, if we have just imagine that we have a substring something like this that looks like A, B, E, B and A. A substring, not substring, a string is something like this. So what we'll be doing using dynamic programming is be first looking for say a given element. So we'll be interested with this center element, that is P. So as I told you first while starting this question itself, that a string will have at least a smaller substring, the most smallest substring, that is a single character, because a single character is considered as a palindrome. So it will definitely have a substring, palindromic substring of length 1. So here let's start with B. Once B is known, what we'll be checking is whether the previous value of B and the next value of B are equal. Because if these two are equal, then definitely this entire thing is also a substring, right? So using the previous knowledge, that is the previous knowledge in this case was that this B is a substring, right? So using that previous knowledge, we check for the previous and the next element, and we got to know that these two are equal. So now we came up to a more optimal solution, that this entire thing is a substring. After that, what we'll do now, we will have this entire thing as a substring. Now we'll be checking for this previous value and this next value, and we'll be checking whether these two elements are equal. Yes, again we find out that these two elements are equal, and because of that we came up to the longest substring, that is the longest palindromic substring this string can have, and that is the string itself, because that framed up to be the longest substring. So what was unique about dynamic programming in this? If we must have used the brute force approach, again we would start making all the substrings, that is A, then AB, AB, and then ABB, and this is how we would go up till how many substring this string is going to consist. And that is where dynamic programming helps, because it uses the previous knowledge, which in this case firstly was B, and because of that this substring was formed, and then this entire substring memory to form even bigger palindromic substring. Let me quickly erase this and head on to our code, which has dynamic programming using two further approaches. So the first approach would be something like this. We are going to slightly increase our space complexity by using a multidimensional array in order to store the substring that are possible. In short, let me explain you by using a simple example. So let me just pick up any of the grids from the given multidimensional array, say this one. Now the thing is, this grid is just going to consist of any of the two values, that is true or false. For demonstration purpose, I'll be considering true as 1 and false as 0. So say that the picked grid has the value of 1. By that what we mean is, from this index, that is from one index which has the value of A, up till this index, that is the third index, which also has the value of A, is a substring. Or in other words, from one index till this third index is a substring. By that thing we mean this. And that's how we'll be storing these results inside this multidimensional array. That means whichever grid consists the value of 1 or through our code true, then what we are going to consider is that from the starting index till the ending index, that is, you can, in short, you can just take this part as left and this part as right, and I hope that is understood. So let us quickly erase this and head on to our code. First things first, let's check whether the length of the given string is 0, that is, it's a null string. Let us then directly return the string, and that's done for a null string. Now what we'll be doing is first creating the array, the multidimensional array I was speaking about, and of course what is the dimensions going to be, that is s dot length and s dot length. So in this case it's going to be 5 and 5. Then we're going to use a memset function. Now what this does is it takes three values, three arguments. First one is the name of the container, so here it is array, the multidimensional array. The second, it takes the value that needs to be assigned to all its elements, so here it is false. And third is the argument in which you specify what is the number of arguments you're going to, number of elements you're going to have in that container. So here we have used the size of array property in order to find out the number of elements. So using this memset function, we have set the false value, or in other words 0 value, to all of the grids in this multidimensional array. So that's self-explanatory, and I would not be writing that in order to explain you. Wherever we are going to encounter a true case, I'm just going to add a 1 over there. Okay. Now let us quickly get back to the code. We have taken a start equals to 0 and max equals to 1. The start is again going to indicate the starting position of the substring, and max is going to indicate the length of the substring. As I told you, we are again going to use dot substring function, and for that we require the starting index and the length of the substring, and that's the reason we have taken these two variables. Now let us quickly look for the substrings, the palindromic substrings which have length 1, and it's quite clear that we are going to traverse through the entire string, and then we are going to make the multidimensional arrays with equal indices as true, because let me first write it 1 1 1 1 and 1. This is what we mean by this given code snippet over here, and the reason for it is just think this way, that a substring starting from B up till B, that is B itself, is going to be a substring. As I had mentioned before, that a single character is definitely going to be a substring, palindromic substring, and same thing applies to A and A as well, and again B and B as well, and that's the reason this pattern follows up for this entire matrix, in which our I is equals to J, or in short, where both the indices are equal. Then our second step requires us to find all the palindromic substrings which have a length of 2. What we'll be doing is we'll be traversing through the entire substring but minus 1. The reason for that is we are going to check for the next index, and that's the reason we are just going for a last but one element, right? Then we are going to check whether that character is equal to the next character, because if those two are, for example, given a substring B, A and A, and our I is currently at index 1, then if it's checking for this, then it's quite evident if this matches with this, so we are going to have a palindromic substring of length 2, and that is what we are going to check over here for. Just those substrings, palindromic substrings, which have a length of 2, and for that we are traversing up till the last but one element, and then we are checking whether the current element is equal to the current character is equal to the next character. If yes, do array of I plus 1 equals to true. For that, let us check in this case what are the positions in which this will apply. So before we do that, it's quite evident that our given input substring, that is BABAB, doesn't have any two successive characters which are equal. That means this is not going to be applied over there. So this for loop will yield no result over here. So heading forward to the main and the most important part of dynamic programming solution, and for that what we are going to do is we are going to check for all the substrings which are of length greater than or equals to 3. So we are starting with int length equals to 3, length less than equals to string dot length, because If the entire string is a palindrome, then we are going to return that as well as the longest palindromic substring. So we are going up till the string.length. And as you can see, our second loop is having a loop variable of left equals to 0. This is basically just going to hold the temporary value of start. As I told you before, start will be used to mark the index of our substring so form, palindromic substring so form, and left in short is just going to hold the temporary value of it. So we are starting from 0, we are going up till the string dot length minus length plus 1. And the reason I have written this is, for this case, just think our string dot length is 5 and our length is starting from 3. So for the first iteration, let it be 3, and we have added a 1. So this would result into 5 minus 3, 2 plus 1, that is 3. So we are going up till less than 3. And the reason for this is quite evident, because that is 0, 1, 2, we are just going up till less than 3, right? 3, so we'll just be going up till 2. And the reason for that is because if we go till the index 2, then we are required to check for a length of 3, and that is the maximum position till where we can check for that. As if we move to the next index, we cannot have a further substring which has a length of 3, and that's the reason for that logic we have done a minus len and plus 1. You can even write less than equals to string dot length minus len, even that will do. After that, what we are going to do is, we are also going to have a right element, as I told in the previous example, given b and a on both sides, as I had given example in the starting. So the reason for that is, since just think if this is going to be our substring at some stage, palindromic substring, then we need to have a left pointer as well and a right pointer as well. And that's when we can check for the next element from the right pointer and the previous element from the left pointer. And that for making that work, we have made int right equals to left plus len minus 1, which in this case would be 0 plus 3 minus 1, that is 2. So till now I've used these markers to denote the position of left, right and start. So it's clear that left is pointing at the 0th index, that is the first place itself, which is marked by green, but our right is pointing at 2, which in this case would be over here, and our start is still 0, so start is also pointing at the 0th index itself. Now coming quickly to the main part, what we are going to check whether a character at the left index, which in this case is this b, and a character at the right index, which in this case is this b. We are going to check whether these two are equal, and yes it is. And the next two conditions you must have figured out by yourself. Those are just for not getting the segmentation fault or array or index out of bound exception. And the main criteria that we are going to check is whether array left plus 1 and right minus 1 is true. And when will this be true? I told you all the true, or in this case all the 1, are going to be a substring. That means, explaining that with the given example below, what first we were checking is whether this a and this a are equal, and then we are going to check from the matrix whether the from the matrix, as I told you, the representation is always from one given point up till the other given point, right? So we are going to check whether our left plus 1, because left is right now pointing over here, right? So we are going to check whether left plus 1 and right minus 1, whether this entire thing is a palindrome. If it is, then of course we are even going to make our array left and right equals to true. That is, we are going to make this entire thing as a palindrome by setting its value as true in our matrix table. Let us quickly look what that would look in the given input case above. So when we check for this, now after checking that array of left plus 1 and right minus 1, which in this case would be left plus 1 would give us 1 because left is still at 0. So left plus 1 would give us 1, and right minus 1, that is 2 minus 1, would give us 1. So we are checking for 1 of 1, and 1 of 1 is 1. So it is a true value. So this condition will be true and it will definitely enter the if condition. Then what we are going to do is, as we came to know that this thing is already a substring, so we are even going to add the left and right and make this entire thing as a substring and display it in the matrix table. And how to display this entire thing as a substring? Using this statement itself, which I just now told, that is array of left right equals to true. So what is left? In this case, left is 0, and what is right? Right is 2. So we need to find 0 and 2. So 0 and 2 would be over here. So we are going to make the value as 1, which will mean that starting from this b up till this b, which is nothing but the same thing, this same thing. So starting from this b up till this b is substring, right? Also at the same time, we are going to check whether the length, which in this case is 3, is greater than max, which was initially set to 1. So yes, it is greater than 1. So we are going to set our max equals to length, and we are going to update the value of start, which will later on help us in order to fetch the substring, which in this case is already at its right position, because left is 0 and start is being equated to left, so it's going to be equal. And that's how we progress again into the loop, shifting left from 0 to a, and then again checking for the next condition with the same length equals to 3, that is for this. And once 3 is done, then we check for length equals to 4, length equals to 5, which is the overall length of the string. This is how it happens, and the main logic, as I told you, is just check whether this entire thing is a palindromic substring or not. Then check whether the left and the right index are a substring or not, are equals to each other or not, and then make this entire thing a substring. And that is how, using the previous knowledge, we used to get even more optimal solution. And that's how dynamic programming uses memory from its subproblems to approach to the optimal solution. I hope that must be clear. If not, just go through my single iteration that I just explained now, and I hope that will get cleared. Now moving finally to but before moving, let us quickly analyze what is the complexity of this solution. So as you can see, we have two loops over here, and that would make the complexity, the time complexity, as order of n square. And but also we are using this extra space of order of n square again. So we are having a time and space complexity both of order of n square. So in order to check what this will result into, let us quickly comment down this code and uncomment our code which we just discussed, in order to check what would approach with space complexity of n square and time complexity of n square would result in. As you can see, we didn't get a time limit exceeded error again, but it's quite evident that this solution is not that optimal, because it's taking 184 milliseconds, which is just faster than 39.09% of C++ submission. Also, if you have a close look on the memory, it's taking 7.8 MB of space, which is not that optimal, right? What we can do is, of course we cannot get down our time complexity, but we'll try to reduce the space complexity to a decent value. For instance, let's say order of 1, that is, we'll try to not include any of extra space by using a multidimensional array in which we will store any of the relations, but directly try to iterate throughout a string and try to figure out from the given subproblems using the same dynamic program approach. So if you must have having a glance through this code, you must be noticing that some of the things are very similar to the previous code. So I'll not be throwing light upon that again, but just mentioning them, and let's look upon the main area of interest. So first, going through the entire code, we have just made the max again equals to 1 and start equals to 0. So by logic, start would be over here, and then we are first going to check, we are going to check for all the repetitions. And the reason we do that is, to give you a quick example in the side, just think that we have a, and we have that is included between a b and b. And why to take again a palindrome? Let's take, which is not overall a palindrome, but we have to calculate, right? So just think I was somewhere over here. So first we try to cover up the entire space. So we come over to here, and then we set our right equals to the last similar value, which in this case would be the index of this a, right? And then what we are going to check, that our left, which will be pointing to the starting index of I, the starting index of the repeated element. Then we are going to check whether the previous element of left and the next element of right are equal, and then we declare that this entire thing is a palindromic sum. So that's the logic again over here. And although again this condition is not going to be applied, for that I just took up one more example, and that would be the same case with this, which you can try on your own. Quickly coming back to our code here, basically first we are setting our left equals to I and right equals to I, which would set our left and right to the respective position, highlighted with green and blue colors. Then we are going to check whether our character at right plus 1 is equals to the character at left. So which would mean that we are going to check whether this A is equal to this B, which is not true in this case, and hence we will not enter the while loop. And that's the reason I gave you this example, which would just be applicable over here, which is first checking for the repeated set of characters, and we are going to set our right directly to the end, to the last repeated character, right? After that, what we are going to do is coming to the main logic again, which would be slightly different than that, hence we are not using extra space. So we'll be checking that first things first, that is, not to get a segmentation fault, we are going to check whether our left minus 1 and our right plus 1 are within the ranges, that is 0 and s dot size, the string dot size or string dot length, anything, you can just use any of these. And then what we are checking whether our right plus 1, as I told you, we are going to check a next value and a previous value, that is left minus 1 and right plus 1. If those two are going to be equal, then this entire thing is going to be declared as a substring. So, and the reason I'm not applying the same to our given input BABAB, because we see over here that our initial condition left minus 1 greater than 0 is not met, because left is already pointing at 0 and left minus 1 would become 0 minus 1, which is minus 1, right? So we'll directly shift, we will nothing will happen over here, and we will directly go for the second iteration. In the second iteration, we have I plus plus, which would update the values of our left and right to I again, which is now our left and right will be pointing to the given indices respectively, marked by green and blue. Now, once that's done, again we are going to check first, of course, the segmentation errors, and then we are going to check whether our right plus 1 is equals to left minus 1. True, because this b is equals to this b, as we saw in the previous problem as well. So what we are going to do, we are going to do a left minus and right plus plus. Criteria over here is, which makes it different from the previous one, is as soon as just in this case as we encountered a, right, and then we check for a left minus 1 and right plus 1 to be equal. And once that's done, we are going to update our left and right value. That means since our left and right both were pointing over here, now we'll make our left point to this by doing a left minus minus. So our left will be pointing to this and our right will be pointing to this. Now what we'll be doing is we'll be recursively checking that. Now we'll be checking whether this is also equals this that is the previous left minus 1 index value is equals to right plus 1, and that's how from a given index we are trying to expand to the maximum length possible, and we will try to do this just till the case when we figure out that, just think here there is a C and there is a D over here which will not match, right? So what we'll do is, after that we will come out of this while loop and we'll be checking for whether our right minus left plus 1. So in this case right was this, so just think our index was starting from here, so 0 1 2 3, so we are checking 3 minus left, that is 1, plus 1, that is 3 again, because in short it's taking the this substring so formed. We are checking whether 3 is greater than max, which was initially initialized to 1. So yes, it is. Then of course we are going to update the max value to this 3. So max will hold the value of 3 using this statement, and then we are going to update the value of start, which will help us later on to form the substring and return the substring, right? So our updated start for the above string would be over in the same place, because there was a left minus minus even during the expanding, because due to the I plus plus and left equals to I agree that our left, which was denoted by green color, had moved to the 1 index, but during expanding, because of the left minus minus, it again came over here. And just think, even if the next there was a character between before this which would match with this, our left would even move further to the left. So right now it's at this, so our start will be updated with the value of left. So in this case it will be B, and in this case also, in the other example that I specified, it will be, right? So this is how, using a single target value over here, you can call it the target value, we are going to first check whether the previous value and next value are equal, then expand, that is point the left variable to the previous index and right variable to the next index, okay? And then again check for the previous, and again for previous of left and next of right, and that's how keep on expanding until the while loop becomes false. And then accordingly check for the max length. If it is greater than the previous time, then update it and make the start pointing to the left in order to easily retrieve the substring which is to be returned. So if you didn't get what it was, just go back and just look at the code again. I hope it will be clear, those concepts will be clear. In short, I would like to again conclude that in the second dynamic programming approach, we are using the way of expanding. We are using a target variable and we are trying to expand it on both the direction. But in the previous one, as you must have seen, we tried to use a separate multidimensional matrix, or you can say array, in which we store the logic for all the substrings, the palindromic substring that appeared, and we set those grids equals to true, or in the representational form as 1. This was all with this approach. Let us quickly go back and do the final part, that is comment the previous code and run this code in order to check what complexity of this code. Let me do that. As you can see, we have got the runtime as 12 milliseconds, which is faster than 94.73% of the online submissions, which clearly says that it's quite optimal. And we have also used the memory usage, which is 6.8 MB, which is definitely lesser than 7.8, because the complexity that was over here, that is the time complexity that we had, was the same, order of n square, and that was because of this for loop and this value, right? And this or this value, both are contributing. And the space complexity, since we are using nothing, would be order 1. And that was all with the last approach, which is the expanding approach using the same dynamic programming approach. So that was all with this question. If you like this video, do hit the like button, and don't forget to share it with your friends who are still looking for a better approach to solve this problem. Also, if you got any doubts or have a better solution than this, let me know in the comment section below. And like always, don't forget to subscribe, because it might be just a button for you, but it does mean a lot than that for me. So don't forget to subscribe. And that was all with this video. I'll be meeting shortly in the next video. Till then, bye bye, take care.